All right, so to finish this off, I want to find the equation of a tangent line, and then kind of work at some of the curves to find the slope of these things. So, example, if I want to find the equation of the tangent line, so example, determine the equation of the tangent line to f of x, which is equal to x squared minus I don't know, minus 8 at 2 comma minus 4. All right. You technically, I don't really have to say that at 2 minus 4. I could have wrote it this way. Instead of saying 2 minus 4, I could have just said that x is equal to 2. And you could actually find that minus 4. You could find that point. So if you want to know what point this thing's go through, your x comma y, the point that it goes through is really going to be x comma f of x. So if you want to know this is going to be 2 comma f of 2. So what I'm going to do is plug 2 into this equation. So 2 squared is 4, minus 8 is minus 4. So that's why I got that 2 minus 4. So sometimes they give it the point 2, and sometimes they just say x equals 2, which means you got to plug it in here to find the y value. All right, so in order to find the slope, what I need is the derivative at 2. So first let's find f prime of x. Well, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So this is going to be the limit as h goes to 0 of x plus h squared minus 8 minus this binomial. Don't forget these parentheses here. X squared minus 8 all over h. And remember, this is x plus h times x plus h. So you're going to have to FOIL that to get x squared plus, outside's going to give you sh, inside's going to give you xh, so it's going to be 2xh plus h squared. And if it helps, you can do this, right? That's what that means. So you're going to have to FOIL that, and that's going to give you this. All right, so, and then I have minus 8, and then distributing this negative is going to be minus x squared plus 8 all over h. And then a bunch of stuff's going to cancel, and then eventually h is going to cancel, and that's going to make our day, so we can find the derivative. So h goes to 0. Well, the x's cancel, the 8's cancel. So I'm going to have 2xh plus h squared all over h. And what's nice is each one of these have an h, so I can factor out that h, and I get 2xh plus, I don't get an h there on my pen, I just get 2x plus h all over h. So these h's are going to cancel, and now I can plug in h equals 0. So this is 2x plus 0, which is equal to 2x. So that's f prime of x. That's just 2x. So if I want to find the equation of the tangent line, you know that your tangent line is going to need, you're going to need a slope, and you're going to need a point. So your slope is going to equal f prime of 2, because it's at that x value. And then your point, I gave it to you. It's going to be 2 comma minus 4. So you're going to use your point slope formula. So a lot of times they say this, but I tend to like to just solve this for y in the beginning. Just write it this way, and then I'm going to pop that point, the slope in there. So f prime of 2. Well, f prime of 2 is plugging 2 into this equation. So f prime of 2 is going to be 2 times 2, which is equal to 4. Sorry for the messiness. So that's f prime of 2, which is 4. And I have this point, so this is going to be 4 times x minus 2 minus that 4. So this 4 is where that slope comes from. And then you have that 2 comma negative 4 for that point. Getting rid of the parentheses. So you get 4x minus 12. So that's the equation of the tangent line. That's the equation of the tangent line, and that's your derivative. All right. The next thing I want to do is just from a graph. Example. Determine the graph of the derivative given the graph of f. Okay, so here's our function, and these points are what you expect. This is negative. These are just -3, -2, -1, 0, 1, 2, 3, 4, 6, 7, and this is 1, 2, 3, and then -1, -2, -3, and so on. So the points are what you expect. So I want to find the graph of this thing's derivative. So it's going to have the same domain here. I'm going to need the same point, so -3, -2, -1, 2, 3, 4, 5, 6, 7. Now remember that the derivative, I keep calling it the slope function because it's technically what it is. So, and I did a bunch of lines here, and I did that because you can find the slope of these lines really quickly. It's just rise over run. So what this has is it has a rise of 3 and a run of 3, so the slope of that particular thing is m is equal to 1. The slope of this line segment from 0 to 2 is going to be, I go down 1, 2, 3, 4, 5, 6. So -6 over 2. So down -6 over 2, -6 over 2 is going to have an m of -3. -6 over 2, -3. This one's easy. This has an m of 0 because it's horizontal. And this has a rise of 1, 2, 3, 4 over 1. So this one has an m of 4. So that's what I'm going to graph. I know I have m equals 1. So technically, remember, this is y, and this is y prime, which essentially is kind of like it's your m, essentially. In this case, it's just going to be your m's. So y prime is your slope, and this is going to be x. So the slope of this from -3 to 0 is just going to be 1. So it's going to go from here to here. Notice that these are open circles and these are closed. Remember, at sharp points, the derivative is not defined. That's why these things are open. The slope here is going to be -3, so I have to go, -3 is going to be our slope, and that's going to be from 1 to 2, so it's going to be -3 from here to here, to 2. Here I have m equals 0 from 2 all the way to 6, so from 2, 3, 4, 5, 6. It's going to have a slope of 0, so it's going to look like this. Then here I have a rise of 4 over 1, so it's going to be 4, so it's going to look like this. That's the equation of the derivative. And that's all I got.